Okay, so we're looking at areas of triangles today, and the formula for this is a half AB sine C. And the first thing we're going to do is find out where this comes from. So here's a triangle, and I've labelled the corners A, B, and C. What I'm going to do is I'm going to draw a perpendicular line from the base, and I'm going to label a few sides. So this side here is A, this side is C, and this side is B. Now the height here I'll call H, and it's actually quite a simple derivation. What we're going to do is we're going to take our knowledge that the area of a triangle is half that of a rectangle. So in this case it's going to be half B times H. So half the base times the height. And I'm going to keep the half B. Remember, we don't want H because we don't know what H is. We won't be given H in questions. If we knew what H was, we'd just use half base times height. So if we know what H is in terms of the angles and the sides, we can work this out as a new formula. So using this angle here of C, if we think about this triangle here, H must equal, well, it's the opposite to this angle, and this is the hypotenuse. So H must equal the hypotenuse times sine of the angle C. This is because of sine, opposite, hypotenuse, and sine. So if H is A sine C, if I substitute it in here, I get half B times by H, which is A sine C. Now, just for the sake of alphabetical order, we actually rewrite this as half A times B times sine C. Okay, so this works to find the area of a triangle when we do not have the perpendicular height. If we have the angle and the two sides either side of it, we can find the area of the triangle. And it's a bit like cosine rule in that it works on having a trapped angle here and a side that we know either side of it. Okay, so here are three triangles where I have an angle and two sides that we know either side of that angle. And I'm going to work out the area of each one of these. So in each case, I'll start with half AB sine C, and we're going to identify C as this angle here. Now it doesn't really matter, you could have it as a half BC sine A or a half AC sine B, but we go with AB sine C because it means you have to learn one formula as opposed to three. And really, you'll be able to label this up quite quickly. So the 5 we can call A, the 6 we can call B. So the formula, when we substitute our values in, is going to be a half times 5 times 6 times sine of 40 degrees. And this gives me an answer to one decimal place of 9.6 centimetres squared. Okay, the next one, start again with a half AB sine C. In this case, we could call 5.5A, 3.2 B. We can go with a half times 5.5 times 3.2 times sine of 120. This gives me an answer of 7.6 meters squared. Okay, final one, half AB sine C, 9 and 9, so A and B are both 9, so it's a half times 9 times 9 times sine of 80. This gives me an answer of 39.9 centimetres squared. A nice way of showing this formula works is that if we take a right-angled triangle, now clearly if we had a right-angled triangle and we knew the base and we knew the height of it, we wouldn't use the half AB sine C, but let's use it anyway and show that it still works. So my angle here is 90 degrees. I have B and H. If I put this into my formula, I have half BH times by sine 90. Now sine 90 from our graph we know is 1. Okay, so this becomes sine 90 is 1, so we have a half b times h times 1, which is a half base times height. So by doing this, with 90 we can show that this formula accounts for any angle. Now what I would say is, you know you wouldn't use this whole formula if you had 90 degrees, but it's nice to know that it works for all angles. And it will work for every angle in between 0 and 180. Clearly you can't draw a triangle which has a reflex angle, it just becomes a triangle on the other side. Okay, so it goes between 0 and 180 and it will work for any angle in that range. Okay, so for these questions we've got a bit of a challenge. Instead of working out the area, we've been given the area and we're going to work backwards to work out either the angle or missing side. So for the first one, if we start by saying we know the area is 300, this must equal my half AB sine C. The first thing I could do is double both sides. This gives me 600 equals AB sine C. Let's fill in what we know. We have 40 times 50 times by sine x. So (40 times 50 is 2,000). So we end up with 600 divided by 2,000, and that equals sine x. So x equals sine to the minus 1 of 3/10. Okay, I'm going to work that out. I get the answer of x equals 17.5 degrees. Okay, in the next example, let's start again by writing that 18.5 equals a half AB sine C. If we double it, we get 37 equals AB sine C. Let's fill in the numbers. 9.5 times by 8.1 times by sine of x. So to find x, we do sine to the minus 1 of 37 divided by 9.5 times 8.1. This gives me an answer of x equals 28.7 degrees. Okay, the final one. We're told that the area is 50. This is going to equal our half AB sine C. So therefore 100 equals AB sine C. A is 2x, B is 3x, and C is 135. So we have 6x squared equals sine 135, and that equals 100. Therefore 6x squared equals 100 divided by sine 135. This gives me an answer of 141.42 ... If I divide this by 6 and then square root it, I have the square root of 141 over 6. So I have the square root of 141.4 over 6, 4.85. we'll round that to 4.9. Okay, so finding x, we find that x is 4.9. We could then go on and find what these two lengths are by times that x value by 2 or 3. Okay, so this is the kind of challenge you're going to have with half AB sine C. You'll have to use it to find areas of triangles, but also you'll need to use it to work backwards.